power grid modernization trends, challenges and opportunities. Myself, Dr. Ms.A.Shiny Pradeepa. I completed my UG in Anna University and ME Power System in Annamalai University and completed my research Ph.D. in University Chennai. I am the head of the department in Electrical and Electronics Engineering. So firstly about the introduction. The power system is a network of electrical components that supplies power from transmission, distribution to the consumers. Power systems are mainly used energy sources like renewable and non-renewable energy sources to generate the electrical energy. Here we can see the structure of electric power system. From the power plants we have to generate the electrical power with the help of renewable and non-renewable energy sources. Then it transmits to the transmission side. In transmission side there are two stages. One is primary transmission and another one is secondary transmission. In primary transmission we are using the step-up transformer. With the help of step-up transformer the power is stepped up and transmitted to the secondary side. Then again the secondary transmission the power is stepped down. On the secondary transmission and the distribution side we have the two types of transformer, that is step-down transformer. In the distribution system itself there are two stages. One is a primary distribution and another one is secondary distribution. So once this power is distributed, it given to the consumers. Here we can easily see that the power is given to the some bulk amount of power given to the industries in the primary distribution side, and the remaining power is given to the consumers. So from the consumer side, for 400 volt for 3 phase and 230 volt for single phase supply is given to the consumers. So what is the necessity of AI in power system means in normally the transmission and distribution side the systems are intermittency in nature, so it can be the voltages varies throughout the day. So the conventional method is not suitable for measure the voltage or analyze the voltage in the transmission and distribution side. That's why we go for the artificial intelligence. So this there are many artificial intelligence techniques are used to evaluate the voltage profile in the both transmission and the distribution side. So this AI is very flexible and adapted to solve the problems. So first we see how we can access or evaluate the voltage profile in the distribution side. There are many conventional methods available in the transmission side. The load flow methods in the conventional methods are Gauss seidel, Newton Raphson and fast decoupled load flow methods. These are the traditional conventional methods we all know. So these conventional methods have both advantages and disadvantages. So first we see about the Gauss seidel advantages. Gauss seidel is a quick number of iterations to reach the convergence. But the main disadvantage is it's iteration based. So if the iteration is very large, if the system size is very large means then it takes more iteration to reach the convergence. So this iteration is directly proportional to the size of the system. Next conventional method is Newton Raphson. Newton Raphson requires less number of iteration to reach the convergence, but the disadvantage is it is a programming logic is very difficult and computational time is also very high to reach the convergence. Next, third method is fast decoupled load flow method, that is FDLF method. In fast decoupled load flow method, the advantages is it takes more number of iterations when compared to the Newton Raphson, but the disadvantages it is very unsuccessful in the high loaded conditions. So these are the three methods which are used in the conventional method in the transmission side. So next we see about what are the limitations in the conventional methods. Limitations means it depends upon the size of the system and it has very more computational time. If the system size is very large means it takes more computational time, and if the size of the system is very large means it takes a more number of iteration to reach the convergence, and it also has a complex problem solution. And the main factor of limitations is ill conditioning. Ill conditioning means once if the Jacobian matrix reaches at the zero condition, then the system we call it as ill conditioning. So these are the limitations available in the conventional side. So the normal voltage levels are we can classify it by various national and international standards as given by certain electric power utility companies. So we have divided into 4 types. One is low voltage, next medium voltage, next third one is high voltage, and fourth one is extra high voltage. Low voltage means the voltage which does not normally exceed above 250 volt. We call it as low voltage. If medium voltage means the voltage which normally exceeds 250 volt but does not exceed 650 volt means we call it as medium voltage. High voltage, the voltage which normally exceeds 650 volt, but less than 33 kV means we call it as a high voltage. Extra high voltage means the voltage exceeding 33 kV, which is under a normal condition, we call it as EHV. Next, for 3-phase AC system, we have classified into 3 levels, 3 voltage levels: low voltage level, medium voltage level, and high voltage level. Low voltage means 100 volt to 1000 volt means we call it as a low voltage level. Medium voltage means greater than above 1 kV, and it is between 1 kV to 35 kV means we call it as a medium voltage. Next, third voltage level is high voltage. The above 35 kV to 230 kV means we call it as high voltage levels. So these are the main standard voltage levels in the electric power system. For a single phase means low voltage, medium voltage, high voltage, and extra high voltage. And a 3-phase AC system means we have classified into 3 voltage levels: low voltage, medium voltage, and high voltage levels. So what are the conventional methods available in the distribution side? In previously we can see what are the conventional methods available in the transmission side. In the transmission side there are three conventional methods we already seen, that is Gauss seidel, neutron traction, and fast decoupled load flow method. In distribution side, these are the 4 conventional methods which is available in the electric power system. One is Newton downhill, next current injection method, hybrid superposition method, and forward backward sweep method. This forward backward sweep method is most available method for distribution side. So each has some advantages and disadvantages in the conventional distribution side methods. So let us see one by one. First is a Newton downhill method. The advantages is it's independent of the initial solution, and it has a very high convergence rate when compared to the NR method. NR is Newton traction method. But the disadvantages is it fails if the Jacobian matrix is singular, which means the Jacobian matrix is 0 means it failed to converge the load flow solution. Next, second is the current injection method. It's a very good convergence even in heavy loaded condition, but it disadvantages, it fails if the distribution generation number is very high. So this is the main drawback in availability current injection method. Next is hybrid superposition method. It does not need any Jacobian matrix, it's the main advantage, but if the system size is very large, if DG size is very high means it failed to converge the load flow solution. Next, fourth method is a forward backward sweep method. Main advantages is it does not need any Jacobian matrix and does not depend upon any PV or DG number, and it has very suitable in both online and offline solution. But the disadvantages when it is very unsuccessful for the heavy loaded condition, and also if the system size is very large means it took some more time to converge the load flow solutions. So these are the 4 methods available in the conventional load flow method in distribution side. 4 methods are now Newton downhill, current injection, hybrid superposition, and forward backward sweep method. While in transmission side the 3 methods are Gauss seidel, Newton traction, and fast decoupled load flow method, FDLF method. Next, what are the AI techniques used in the distribution load flow means there are many AI techniques that are used. First one is a genetic algorithm. It has both methods has similar merits and demerits. Let us see one by one. So first one is genetic algorithm. Genetic algorithm is very simple to implement and it is suitable in offline problems also, but the disadvantage is it took some more computational time to reach the convergence. So next is a particle swarm optimization method, that is the PSO method. The main advantage is it's suitable for offline problems and it's very faster when compared to the genetic algorithm method. But disadvantages, it is a very slower in convergence and in complex network it is very unsuccessful. Next, third method is a fuzzy logic. It is simple to implement and it has a very high precision and rapid operation. And the disadvantages, for more accuracy we need more fuzzy grades to develop the convergence. So let's see what are all the researchers took the solutions in the distribution side. So in this paper, the paper title is an adaptive distributionally robust model for 3-phase distribution network. So this paper is published in 2021. Here we can see they took distributional robust model for 3-phase unbalanced network. Here they are using a IEEE 33 bus test system. The main drawback is the computational time is very high, and this the proposed method, it took very less iterations to reach the convergence. So for number of iterations, it is 2 means the computational time is 71.061 seconds to reach the convergence rate, and for another system the number of iteration is 8 and it took 95.919 seconds to reach the convergence. Next second paper is the physics aware neural network for distribution system state estimation. This paper is published in the year 2020. Here they are using a novel learning based model for real time monitoring in distribution network. Here they are using IEEE 37 distribution feeder for the for evaluation. Here they are using the proposed method is a greedy algorithm for monitoring the voltage level, and hence they are using a novel learning method that utilizes the structure of the power grid. Next third paper is machine learning based real time monitoring of long term voltage stability using voltage stability indices, and this paper is published in IET Generation Transmission and Distribution, and this paper published in 2020, and here they are using IEEE 14 bus system and IEEE 118 bus system. They are using a 2 bus systems, and here the proposed method they are using is a machine learning approach to predict the long term voltage stability margin as represented by the load ability margin, and the proposed method uses a here they are using only selected set of inputs given as an inputs to evaluate the voltage profile, and this proposed method utilizes an ensemble of machine learning regression model which uses selected set of inputs as a load indices to evaluate the voltage profile for the machine learning models. And next is the effect of suitable network modeling in voltage stability assessment. So this paper is published in IEEE Transaction. Here they are using a time domain simulation on simple system shows that if different reasons that may cause the occurrence of the voltage instability, and here they are using a DigiSilence software which is used to change in the transmission and distribution impedance and tap changer limits. In all the cases the loading factor is increased until the voltage collapse is observed. So the voltage stability assessment can be done using the static analysis with the replacement of the distribution network by the suitable load model. But the loading ability limit of the distribution and transmission can be calculated separately, and whichever is smaller it can be considered as a system load ability limit. Next here they are using a neural network based load modeling, and it is used in by using the voltage stability analysis. This paper is published in the year 2017, and the journal is IEEE Transaction on Sustainable Energy. So here they are using IEEE 14 bus system. Here they are used both static and dynamic voltage stability analysis are performed with the use of neural network methodology. The proposed method is neural network methodology for dealing this with the static and dynamic load modeling. And this static load modeling which may not be suitable for the load dynamics, while the dynamic voltage stability is too time consuming, which will affect this effect on the use for online voltage stability indices. And the static voltage stability indices may not be sufficient, and this dynamic voltage stability indices which means more grades will be limited. And next is a linear 3-phase load for the power distribution. So here for 3-phase unbalanced system they are using IEEE 37 bus test feeder they are using, and here they used the conventional method of linear power flow which is based on rectangular formulation, and here they are using a forward backward sweep algorithm as a proposed method, and this linear flow method gives very relatively low errors even in highly loaded conditions. Next paper we can see the power system analysis toolbox. This is a PSAT toolbox. Nowadays they are using many researchers are using this toolbox to evaluate the voltage profile in the distribution side. This is a free software, the open source software. This is initially free software which is used in all the power system analysis. This provides a complete set of user-friendly graphical interface and Simulink based editor on online network diagram. And the PSAT includes power flow, continual power flow, optimal power flow, small signal stability analysis and time domain simulation, as well as a severe static and dynamic models including the non-conventional loads, synchronous and asynchronous machines, regulators and factors and fact devices. These are all factors which is available in this PSAT software toolbox. So the PSAT software toolbox has wide range of time frame
with starting of microseconds when simulating the fast electromagnetic transient, and it is extended to several years in system planning devices. And what are all the tools which are available in this are Mat Power Toolbox, Power System Toolbox, Electromagnetic Transient Program, Power System Analysis Toolbox, Voltage Stability Toolbox, Power Analysis Toolbox, Education Simulation Toolbox, and Sim Powers Toolbox. These are all the softwares and which is open source and freely user friendly softwares which is available in the power system analysis. So the next is the MATLAB toolbox used in the power system analysis includes a set of application function, and it collects their inputs and provide the outputs in the form of the proposed presentation. The next is PSAT. Power system analysis is demonstrated by the Frederick Milano in the year 2001. First they published with the PSAT completed in the year of November 2002. So this PSAT is a MATLAB toolbox for electrical power simulation analysis and control, and it's both available in static and dynamic analysis also. One of the power flow can be solved further with dynamic and static and dynamic analysis can be performed in this PSAT toolbox. I already explained that PSAT includes the power flow, continual power flow, optimal power flow, small signal stability, dynamic domain analysis, phasor measurement, graphical user measurement, and graphical interface editor. These all the factors which are available in this PSAT analysis toolbox, that is PSAT toolbox, PSAT toolbox. This is the normal general or 52 distribution system. This is done by using this single diagram by using the PSAT analysis toolbox. Here we can see this distribution side network. So next we see about the recent artificial intelligence technique which is used to available in this distribution side. So GRNN, that is generalized regression neural network, that is we call it as expression of GRNN. This GRNN was developed by DF Specht in the year 1991. This GRNN is suitable in both online and offline dynamic systems. It is based on non-parametric regression. Here there are three types available in this GRNN, three stages. One is a regression, second stage is a prediction, and third is a classification. And we can implement this GRNN in MATLAB software also and R programming, and it is also suitable in Python language programs. So that is very user friendly and easy to implement, and we can evaluate the voltage profile with less number with less iterations, and with quicker iteration and with less number of computational time we can evaluate the voltage profile by using this AI, that is GRNN, generalized regression neural network. So what are the advantages in GRNN is, so it has a no back propagation and it has a very high accuracy, and irrespective to the size of the system with very high reasonable accuracy we can use this GRNN network. So this is a sample diagram which I have pasted in this picture. Here we can see the three boxes. One is constant box. Next, the center box displays the generalized neural network, regression neural network, and the third box represents the display box, that is the output voltage profile. So once we have given this input values in the constant box, we have to click this constant box. We have given the input values. So next we have to run the assembling, then we can get the output voltage profile in this display box. So for artificial intelligence, AI can be used in power grids to improve the operational efficiency, and we can increase the flexibility and also to reduce the risk of blackouts. So this AI can helpful with the variety of tasks including monitoring, prediction, optimization, and integration and responding. So monitoring means AI can monitor energy usage and it detects the abnormalities and it provides the real-time data on power consumption. Next, prediction. Prediction means AI can predict demand and supply fluctuations and also forecast the energy demand and supply. Next, third is optimization. Optimization means this AI can optimize the energy resources and it can control the specific grid operations. Next, fourth is integration stage. In integration, this AI will be very helpful for integrate the renewable energy resources into the power grids. such as solar, wind, etc. Next is last stage is responding. This AI can respond to the vulnerable parts of the power grids, and such as also it is also helpful for rerouting the power or storing the energy surplus in this power system. So next we see about the smart grid, how the artificial intelligence is powering this today's energy technologies. So a smart grid is a network that integrates energy distribution and digital communication technology in a two-way flow of electricity and data. So this enables the utility companies to optimize the generation, transmission and distribution of the electrical power. And it also allows consumers to benefit from stories, and all the data is telling the helpful them to better understand the energy they use and even the energy they produce and store through things like solar panels and electric vehicle batteries. So what is the difference between the traditional, conventional and smart grid and the smart grid? The main difference in the traditional system and smart grid lies in the ability to exchange the information in both direction across the network from utility companies to consumer side, and vice versa, both in consumer and utility also. Some of the top features that demonstrate the smart grid includes: one is technology, second distribution, and third generation, fourth sensors, and fifth is self-repair and predictive maintenance, and sixth is consumer choice. Let's see one by one. So first is technology. So artificial intelligence and cloud computing and digital technologies allows all the devices and it assists within the grid to communicate the systems and supporting the better control and self-regulation to the consumers. Second stage is distribution, and energy generated by the prosumers and other renewable energy resources such as solar, wind, which can be intermittency in system. So the smart grid technology helps to coordinate, store and distribute the power from resources generating stations to the reliable side and the consumers. Next, third is generation. So predictive analysis in the smart system is which can helpful for high demand strains that can be forecasted and distributed to multiple power plants and the substations. Next is sensors. So IoT sensors across the network can help detect risk earlier on redistributing power to decrease the outages and help in balancing loads without direct intervention by the operators. Next is self-repair and predictive maintenance. Sensors can be also be used to detect the mechanical problems, and it can do the simple troubleshooting, and it can repair, and it can also send notification message to the technicians only when necessary before anything actually breakdown appears. Next is customer choice. More energy suppliers and cooperatives and micro generators can join the grid, and it allowing the consumers to have more choices in how they receive this electrical energy. So next is application of artificial intelligence in smart energy solutions. So the artificial intelligence in the driving intelligent agent behind smart grids. It can evaluate the environment and it taking necessary actions to maximize the driven goal. AI is fundamental to integration of renewable energy, the stabilization of energy networks, and the reduction of financial risk which is associated with instability in the infrastructure. So let's see next how today's utilities industry is preparing for the smart grids of the future. So the communicating the vision of the smart grid and aligning teams and the stakeholders around it, and we can strengthen the consumers education about the challenges, changes and opportunities in the upcoming AI, and we can provide win-win motivation for the consumers and prosumers and potential distribution partners. Then we have to develop the matrices to monitor the progress in the implementation and effectiveness of smart grids, and we have to keep the consumer experience and customer retention in mind, and we have to give the additional competition and decentralization of the smart energy markets. So once again I summarize what are the things we have discussed in this session. So first we see about this normal generation structure of electric power system. So which means there is a structure of electric power system is 3 stages. So one is generation, second is transmission, and third one is distribution. In generation, we have to generate the electrical power with the help of renewable and non-renewable energy resources. Next, we have to generate the power is given to the transmission side. In the transmission side, we have using the step up and step down transformer to transmit the electric power. Next, it given to the distribution side. In distribution side also there are two stages, one is a primary transmission and secondary transmission. In primary transmission, some amount of bulk amount of power is given to the industries, and finally we had distribute the power to the consumers, 400 volt for 3 phase and 230 volt for single phase system. Next we see about what are all the necessity and in the AI, and what are the advantages of the AI, which is very flexible and adapted to solve the problems while access the voltage profile. And next we see about the conventional methods, that is Gauss-Seidel, Newton-Raphson, fast decoupled load flow method, and both three methods have similar advantages and disadvantages. And next is the limitations. So limitation is conventional is depends upon the iteration is mainly depends upon the size of the system. If the size of the system increases means it took some more iteration to converge the output solution. Next, voltage levels. What are the standard voltage levels classifications in the national wide? There are 4 stages, low voltage, medium voltage, high voltage and extra high voltage. And 3 phase, when it comes to 3 phase, there are 3 stages, one is low voltage, medium and high voltage. And next is what are the conventional methods available in the distribution side. There are 4 methods: Newton downhill, current injection, hybrid superposition method, and forward backward sweep method. Next, what are the AI techniques available in the load flow solution: genetic algorithm, particle swarm and fuzzy logic. Next, we see about the recent researchers that they have analyzed the access the voltage profile by using the proposed AI techniques. And we have seen about the free open source software, that is PSAT analysis toolbox. And these are the diagram which can be drawn with the help of PSAT analysis toolbox. Next, we see about we have seen about this GRN and genetic regression, generalized regression neural network model, how it is implemented in the MATLAB softwares, and what are the advantages in the GRN network. And we can sample, we can see this simulation diagram by using the help of AI generalized regression neural network. Next, we see about the artificial intelligence. So these are all the methods in the electrical modernization in the trends in this power system. So if you have any queries means you can just mail with the HOD@psnchat.ac.in. Thank you.